Okay, today we're going to learn about linear programming. This is notes day number 10. And we're actually combining 2 days of notes, 10 and 11. Because of PSAT day, we got to double up a little bit. Linear programming is just a way to solve a system of linear inequalities so that we get a maximum profit or a maximum income or a minimum loss. It's really not that complicated. It's just a lot of steps. So we're going to take them one at a time. We're going to start with one that is not a word problem so that you can get all the mechanics, and then we'll move on and do a word problem on the back. Okay, so using linear programming, find the values of x and y that maximize and minimize the objective function p equals 10x plus 15y. This is like your profit equation. Think about it like it's $10 for every x, it's $15 for every y. What's my profit? Okay, if I sell one x and one y, my profit would be 25. So they've given us some restrictions. They said that when you add x and y, you have to get less than or equal to 16. So what I'm going to do is I'm going to use the intercept method. We could solve for y and graph it using slope-intercept, but since they're in standard form, it's usually easier to just use your intercepts. So the x-intercept for the first equation is 16. So I'm going to go down to my graph, and I'm going to count over 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and there's 16. Okay, now I'm going to find the y-intercept. So I'm going to go back up to my equation, cover up the y, or cover up the x so I can get the y-intercept, and my y-intercept is also 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and there's 16. Okay, so now I'm going to draw in that line. Now, it's a solid line because it was less than or equal to, and we would be shading below the line because it is less than. I'm not going to color it in fully because we're going to look for an overlap here in just a second. Okay, now I'm going to grab a second color. I'm going to use brown. Yeah, maybe not. Brown's not going to show up too well. I'm going to use pink. My second equation, my x-intercept would be 3x equals 60, so x is 20. So 15, 16, 17, 18, 19, 20. My y-intercept would be 10, because 6y is less than or equal to 60. So right there. And now I am going to draw in that line. Now that one is less than. So that would be all of this. And what we're looking for is where the two graphs, the pink and the red, would overlap. And that would be right here. And that is our solution area. Now, you're probably wondering why we have x greater than 0 and y greater than 0. In the real world, we're not going to sell less than 0 of something. So we're not going to go below 0 for either the x or the y. Only going to work with the first quadrant. Okay, so we have graphed the restrictions. Now it says find the coordinates of each vertex of the region. We can ignore this one because it's not part of the shaded part. We can ignore this one because it's not part of the shaded part. But here we have 0, 0, 16, 0, and 0, 10. What we don't know is this point right here, that intersection point. And no matter how accurate you graph, that's really hard to find, at least by hand. but it's really easy to find with a matrix. If you go back up to your equations, our two equations were x plus y equals 16 and 3x plus 6y equals 60. We want to know where those two lines cross. Well, all we need is to do a matrix. We could have done elimination, we could have done substitution, but the matrix is the easiest way to handle this one. Okay, so at this point I would pull out my calculator and I would work this out, and I'm going to get 12,4. So we've now found the coordinates of each vertex of the region. So the last step is to evaluate P at each vertex. To do that, I just make a quick table. I've got X and Y, and I've got P, which is 10X plus 15Y. Now you can use your calculator to do this, but it's really not that hard to do it by hand either. 0, 0, 16, 0, 12, 4, and 0, 10. So at 0, 0, you'd have 10 times 0 plus 15 times 0, which is 0. At 16, 0, we would have 10 times 16, which is 160, plus 15 times 0, so just 160. Here we're going to have 120 plus 60, which is 180, and at 0, 10 we would have 150. So for this problem, my minimum value is 0, and my maximum value is 180. Okay, how do we feel about that? Pretty good? Okay.